This angle's small and skinny and kinda cute. It looks like a V or the top of a Y, or the angles that you see eating pizza or pie.
Angles are measured in degrees, and here's how to remember them with ease.
When an angle measures 90, do we call it right? You can tell this angle just by sight. It looks like an L or the corner of a square. You're looking at them when you're walking up the stairs.
Angles are measured in degrees, and here's how to remember them with ease.
From 90 to 180, an angle is obtuse. This angle's kinda fat, it's got a big caboose. Like the hands on the clock when it's 1:45, or the antlers on the head of a full-grown moose.
Angles are measured in degrees, and here's how to remember them with ease.
To measure an angle's degrees with a protractor, place the vertex at the hole in the center. Line up one ray at 0 on the protractor. Remember that the 0 can be on top or under. Count up to where the other ray points at the number. That will be the angle's measure.
Angles are measured in degrees, and here's how to remember them with ease.
Welcome everyone to 1.5 in our Big Ideas Geometry curriculum. We're looking at measuring and constructing angles, and that song just kind of got us ready for this lesson. We're going to be naming these angles and classifying them, measuring them, and we're going to look at more of the measuring and constructing part of it kind of as worksheets in class or doing some of those in class activities. We're just going to get the idea of definitely naming the angles, looking at the angle addition postulate, which is similar to the segment addition, and also looking at bisecting angles, which is similar to segment bisectors as well. So before we get into all of that, let's take a little joke, or not joke, but a cartoon of our day here. Danger, watch out for warning signs placed right in the middle of the ski slope. So the guy whacks right into it. It's probably covered with snow. Couldn't see it. Nice sign right there. All right, so as we get into our naming the angles, so this is on page 24 in your vocabulary. There's quite a bit of vocabulary here to look at. So first of all, just angle, vertex, and side. In this first one, you want to draw this out. You want to draw the angle out in this picture out right here, because really this is better almost than just writing out the definitions, because you can see, okay, that is the vertex. It's the corner. So at the sides are these two rays right here. And so it definitely gives you, as far as vertex and sides. An angle is a set of points consisting of two different rays that have the same endpoint, called the vertex. And so that's what you want to do. You can go ahead and write this part out here, that an angle is a set of points consisting of two different rays, the same endpoint, and then go ahead and draw this for that as well. And we can name angles three different ways here with using these bullet points. So go ahead and write these bullet points down right here. So you want to write this part down as far as how you would name an angle. So you could use its vertex. If the vertex here is point A, so you could say it's angle A using that vertex right there. You could use a point on each ray and the vertex, such as B, C, and A, or C, A, and B. So you can say angle BCA or ACB, or BAC or CAB. Sorry, A needs to be in the middle. And it needs to go exactly that way. We could not say ABC, because that's not the angle ABC. The middle one, the vertex, definitely has to be right there in the middle of how you would say that if you're going to use the three letters on the angle. There's the other way you can do it. If the angle is numbered, you can use the number that it's numbered there. This could be angle 1 using that 1 that's right here. So you could use this number here. You could use just saying angle A, or you can use all three letters as long as you put the A in the middle. And don't forget, notice we were using this little angle to put in front of that. So that definitely tells us it's angle BAC, or angle 1, or angle A. And then as far as interior, exterior goes down below here, you can go again, draw the angle out. You can write interior on the inside, and that's just going to be all the space. As these keep going up, you're going to have the interior is going to get bigger and bigger. The exterior is everything that's on the outside of the angle in the blue section here. So the region that contains all the points between the sides of an angle is the interior. That's the definition. You want to write that definition down as well as draw the picture. So don't forget to draw the picture. That does definitely help. So that's what the interior of the angle is. It's the region that contains all the points between the sides. The region that it contains all the points outside the angle is the exterior, and you can write that for exterior. So it's the region that contains all the points on the outside of the angle. Okay, so that's just your vocabulary there, at least first like 5 of them. That will take us into a couple things here that we want to put down. So right there on page 24, right below your vocabulary for those, go ahead and put 1 through 3. You can go ahead and draw these angles out just the best. You can just sketch them real quick with PQR on number 1, XYZ on number 2, and DEF on 3. And what we want to do is we want to write 3 names for the angle. I'll show you number 1, and then I'll let you try number 2 and 3 on your own. So for number 1, we can name this. One way we can name it is just using the vertex letter Q, angle Q, or we could use the 3 letters here. We can go PQR, and we can also say RQP, as long as Q is in the middle of those letters. And so that's the 3 ways you can name this one. Go ahead and write these down: angle Q, angle PQR, or angle RQP. So the same thing for number 2. This one actually gives them numbers in the middle, so you can use those numbers as well. But write the 3 names. In fact, there's really 4 on this one, so might as well just write 4 of them. There's actually 4 names on this one. This one only had 3 because it did not include a number in here. This one includes the number, so it has an extra one. So it says write 3, write all 4 of them. So go ahead and do that. Go ahead and pause the video and do that for 2 and 3, and then play it and see if you got all 4 correct. Okay, so hopefully you paused it. You got the 4 different ways you can name this angle for number 2. So we could name it with just angle 1. We can name it as angle Y, or we can use the letters as long as we put Y in the middle, X, Y, Z, or Z, Y, X. So that's the 4 ways you could do it there. This one, you can name it with the number, angle 2. You can name it with the vertex letter E, angle E, or you can name it with the 3 letters D, E, F, or F, E, D, as long as E is in the middle. And there's the 4 different ways we could do that one. All right, so if you didn't include one of those, go ahead and write that down and include that. Make sure you wrote that down there on page 24 where that vocabulary is that we just had written down about naming the angles. Okay, so now turn over to page 26. We're going to take a look at our extra practice here for 1 through 3. And it says name 3 different angles in the diagram. So the diagram doesn't just give us one angle, it gives us a couple different angles with the way it is here. So you got one big angle here with a ray going through, really creating 3 different angles here. So you have the one up on top, the one down below, and then the one that's between the top and bottom rays. So we can name the 3 different angles here. Now since F has really 3 lines going to it, not just 2 rays are coming from F, it's a vertex really for all 3. You cannot say angle F. So if you said, I'm going to name this angle F, well, which one are you talking about? Are you talking about the top one, the bottom one, or this one? So you can't use angle F on this one. You have to use the 3 letters with these points up here. So let me do the first one for you, and then you can try 2 and 3. So we can name this first one. The first one we can name is EFG. That's the top one here, E, F, and G. As long as, again, F is going to be in the middle because it's the vertex there. And so angle EFG. Another one we can name it is HFG. So using the bottom one with F and G. So that's another angle, this bottom angle here. Again, F's in the middle. And the third angle that we see here is the big one, EFH. So EFH. Now you could have also said angle HFE, and that would have been okay. So we could have also said for this one, GFE. We could have said it that way. So it's okay as long as F stays in the middle. The vertex has to be in the middle. That's the main thing. So those are the 3 different angles. We want a name for each of the angles. So now go ahead and pause the video and do the same thing for number 2 and 3. Give the 3 names for the 3 different angles that you see in 2 and 3. All right, hopefully you've paused it and you're pausing it, you're starting again to check that. So we could have a QRT, and you could have said TRQ as long as R was in the middle. That would have been okay. So that's that angle. Another one is SRT. So SRT is this one, or you could have said TRS. That would have been the same angle. That would have been okay. And the last one is QRS, the big one. So QRS this way, or you could have said SRQ. Either one would have been fine. And number 3, you could have started off with LMN. So that's this angle here. LM to N, or NML would have been the same thing. Another different angle is KMN, that's on this side, KMN, that's this angle here. You could have said NMK and would have been okay as well. And then there's angle LMK, so LMK here, and that's another angle here. You could have gone backwards and said KM and L. Okay, so that's the 3 angles, 3 different angles. So it just, when you have 3 rays coming out from the same vertex, you're going to have 3 different angles. And you can name each one using those points. All right, well, the video at the very beginning kind of did a pretty good job at explaining a protractor. It did say you're going to start the vertex of the angle right there at the 0, right here at the center of this protractor. So there's always going to be a starting point where you're going to put the vertex, and it'll be clear on a protractor. And we're going to get these protractors out and actually work with them in class, but just so you get the idea, the vertex will go there at 0. Sometimes that's actually a hole that goes through, so you can put a pencil through it. And then your angle is going to need to be straight on this line right here. So straight on that line, or if you wanted to tilt this line here would need to be straight on this line. So one of your rays needs to be straight, going straight on this one, pointing at 0, either one way or the other way. And now you can see the other angle going this way. Now you notice there are 2 different sets of numbers going along here. So if your straight line is headed this direction, that means that this is 0 degrees right here where that straight line is. You're going to use the inside numbers. And then to check this, and where we're seeing this one land is at 140 degrees. So this angle is a 140 degree angle. If it was going the other direction, if the straight line was coming this way, then that's 0 degrees this way, and we're going to use the outside numbers then to calculate that angle. So if it was doing that, we could do the same thing and calculate it that way with the outside numbers. So here's a vocabulary word, measure. So the measure of the angle AOB, which can be written as M in front. So if we're just talking about the angle, we're going to just say angle AOB. But if we're going to actually give it a degree, like the measure is 40 degrees, we want to put a little M in front of our angle. So that way it says the measure of angle AOB is 140 degrees then. So it's equal to the absolute value of the distance between the real numbers matched with these 2 rays here. And you can just see the 2 rays, you get 0, 140, the absolute value between those 2, just in case you might have had an angle going this way too. So it doesn't have to, I guess, be right there on the 0 if you're using the absolute value of the difference between those, or the distance between those. So if we had another angle going up here and it was going through 60, you could say, okay, 140 minus 60, that would give you that number right in there. And it would just always be a positive number because absolute value always would turn positive. Okay, our next core concept is about the types of angles. There's these 4 types, and this was on the video. So this was what the main part of the video was, except it did leave out one of them. It left out the straight angle, which is just a straight line going across, and that measures 180 degrees. But it did talk about these first 3, so you don't need to write these down in the vocabulary because they are here in your core concept. Just go ahead and highlight them like they're highlighted here. So the acute is going to measure between 0 and 90 degrees right there. So less than 90 degrees, it's going to be called acute. A right angle is going to be exactly 90 degrees right there, just like a corner, perfect corner there of a square or something. Obtuse is when it's going past 90 and now it's between, it's more than 90 degrees. So as soon as it gets to become more than 90 degrees, between 90 and 180 usually, that's going to be, so it's greater than 90, less than 180, that's going to be called obtuse. And when it's exactly 180, we call it a straight angle. So a couple exact ones there, exactly 90 is right, exactly 180 is straight. But then there's a range. Acute is everything from 0, greater than 0, less than 90. Obtuse is everything that's greater than 90, less than 180. All right, so on page 25, right there below that protractor one, We're going to go ahead and look at these. I'm going to have you write these ones down, though. We'll do these kind of right now. You can just watch A, B, and C, but you're going to write on your notes, you're going to write 4, 5, and 6. We're going to still use the same protractor for those. So for letter A, G, H, K, it says to measure, find the measure, and then classify the angle, which would be one of those 4 words that we just looked at. So G, H, K, so we're looking at G, H, and K. So that's this angle right here. Now this one, G, starts at 0. So really we can just look at our outside numbers and go all the way along until we get to K, where the ray for K is here, HK ray, and see where that is. So that's going to be, looks like somewhere between 120 and 130. Looks like pretty close to 125 on that one. I mean, it could maybe be 124, but I think it's 125. Yep, it is 125 exactly. And so we would call that obtuse because it is more than 90. J, H, and L. So J is over here, and then we got H, and then L. So going straight up, and that's exactly 90 degrees right there. So that one's going straight up through 90, and you're going to use these numbers here at the beginning, the inside numbers to show, okay, that's 90 degrees exactly, right angle. C is L, H, and K. So L, H, and K. So that's these two right here. And so we're going to have to use the difference here. We're going to have to do some subtraction because we're not right at 0 this time. We're at 125. We know that on the outside number going to 90. Or if we use the inside numbers, it's going to be, we can do the inside ones as well. We could do 45. No, is that not 45? 55, sorry. That's 55 right there. Going to 90. So 90 minus 55 would work to find that angle. 90 minus 55 is 35 degrees, and so it's acute because it's less than 90. All right, so number 4, 5, and 6. Go ahead and do the same thing with JHM. That's the one to start with. So JHM, do that one, MHK, and then MHL. So go ahead and pause the video and find the degree measure, and then also classify it with which name is it. Is it acute, right, obtuse, or straight? Okay, so hopefully you did that. It should be done right there on page 25, right where you have some note sections in there. There's not a lot of space there, but you could fit this in, I think, just to put down the letters and then how many degrees and what name is it. So for this one, let's go ahead and actually going to look at the answers on this side over here. So for JHM, that one was 145 degrees and it is obtuse. So definitely we know it's obtuse when it's more than 90. So you can see it's going right through 145 degrees. So if you start here at 0, J, all the way over here to M, that's the inside number, that's 145. MHK, so M, H, and K here, so that's these ones right here. Here you're going to need to subtract. So we could go from 55 all the way over to 145. So basically 145 minus 55, and that is exactly 90 degrees. It's a right angle, and it's exactly 90. And then MHL, that answer was 55 degrees, and that one is acute. It's less than 90. So for that one, MHL right here. So you could have done, you could have used the outside numbers if you wanted to. You could have said 90 minus 35, and that would have worked and given you 55 that way. So that would have been an easy one to do. And that gives you an acute angle. All right, here we'll pause for our joke of the day. So what is a scarecrow's favorite fruit? Did you ever think about that? Scarecrow's favorite fruit. Strawberries. Oh, of course, strawberries. Scarecrow's made of straw. Okay, we have another vocabulary word to put back on page 24. So two angles are congruent angles when they have the same measure. So congruent angles are angles, two angles, that have the same measure. Whoops, don't cross that out. I'm trying to underline it there. Have the same measure. That's what you're trying to do. So they have the same measure. So go ahead and write that down on page 24 under the vocabulary. You can go ahead and look at this one. Now, again, congruent symbols. We talked about congruent symbols before with segments. The symbol is still going to be the same with an equal sign and like a little kind of squiggly above it. That's still the congruent symbol for angles. But when you actually look at the diagram, now instead of the marks that are straight, that's going to be for a segment. We're going to see these arcs here. So here G has got 1 and F here has got 2. Down here in this one, B has got 1 and D has 2. So what that tells you is that G has got to be congruent to B and F is congruent to D. That means they're the same measure. And so that's right. It's saying here, if you know the measure of angle ADC is 140, so ADC, if you look at where ADC is, that's this one here, then what's the measure of EFG? So EFG is this one, so since those have the same marks, they're congruent, we know it's the same thing, so it's also 140. And there's the congruent symbols again with the angles, but we would say that yes, they're congruent. Two pairs of congruent angles. Oh yeah, I was doing B, so yeah, B right here, that's 140. We can also say if we know what G is, we would know what B is here as well. Okay, so we look at the next, this one's a postulate, angle addition postulate. So much like segment addition, angle addition is the same thing. We're adding two angles together to get a bigger angle. So if we know, these two smaller angles, if we know the degree of each of these, we could add them together to get the bigger angle. Or if we know the bigger angles measure, and we know one of these smaller ones, we could do subtraction to find the other one. We could take the bigger one minus the smaller one. It's going to give us the other smaller one. So that's what we can do there. It shows you this like little equation that the bigger one is equal to the two smaller ones added together. That's just angle addition postulate. So it's a lot like the segment addition, except just with angles. Okay, so back on page 26, we're looking at number 4 through 6 in our extra practice. Number 4 it says find the measure of angle JKL. First, identify which one you're trying to find. JKL is the bigger one. We know the two smaller ones here. So just a little angle addition. We just got to add those two together. So the measure of angle JKL is equal to 31 plus 85. And so when you add 31 and 85 together, you're going to get 116 degrees. That's the measure of angle JKL. Number 5. This one tells us up here that the measure of angle RSU, so RSU is the big one, is 91 degrees. So it's almost a right angle, just it's still obtuse though because it's more than 90. It says find the measure of RST. That's this one here, the smaller one that we don't know. We do know this other side is 69. It shows us in the diagram. So we're going to have to do a little subtraction on this one. So as we set this up, the bigger angle is 91, so we start with that. Start with the bigger one. 91 degrees equals, let's do the one we're trying to find here, RST. The measure of RST plus the other one that we know is 69. So now all I have to do is just subtract 69 from 91. So minus 69, 91 minus 61, or 91 minus 69 is 22. So the measure of the one we're looking for, RST, is 22 degrees. And then for number 6, we got, it says, tells us right here that this UWX here, UWX is a straight angle. So we know if it's a straight angle, it exactly equals 180 degrees. It says find the measure of UWV. So UWV and find the measure of XWV this side as well. So find the measure of each of these sides here if this is 180 degrees straight across. So we want to start with the bigger angle. The bigger angle is 180 degrees, so we start with 180 equals these two smaller ones added together. So this one is x plus 20. So we write that down, and we're going to add it to the other side, which is just x. And that sets up our equation that we just want to solve here for x. So first combine like terms, getting 2x on that side. And then we would just subtract 20 from both sides. So 180 minus 20 gives us 160. That's equal to 2x, and then divide by 2. And so that gives us x equaling 80. And then when we plug it back in to this one that just has x degrees, that is 80 degrees. So the measure of XWV is equal to 80 degrees. And then this one's going to be 80 plus 20, which would be 100 on that side. So the measure of angle UWV is 100 degrees. Now notice I'm putting measure here when I'm trying to just tell them what the degree is. So when you're actually saying how many degrees it is, you write the word, or write the little letter M in front to show measure on that. Okay, so we do have one more vocabulary on this one, which is angle bisector. So again, that's a lot like the segment bisector. It's an array that's going to divide an angle into two angles that are congruent. So an angle bisector is only going to really be a ray because it's going to stem from the vertex here, and it goes right there in the middle, and it basically makes these into two congruent angles here. So the top angle is exactly the same as the bottom, and notice the congruent marks in here, or little arcs here, showing that those angles are congruent. So when you see these little marks, they mean something. They mean these are the same measure. They're going to have the same measure. So if you find the measure of this one, then you've also found the measure of the bottom one. So go ahead and make sure you copy that down there. It's an array that divides an angle into two angles that are congruent. That's an angle bisector. Alright, so continuing on with our extra practice numbers 7 through 9. 7 does show us in the diagram that the angle BAC, or just even angle A, we could call it, is a 90-degree angle. It's got the little right angle mark right there showing it's at 90 degrees. And we have each angle here given as an expression. We're trying to find the measure of each one. So if these both add up to 90 degrees, that's what we could start with. Start with the bigger one, which is 90 degrees, equal to these two adding to each other. So x plus 15 plus 5x plus 57, and that makes our equation. So remember, you're a lot of times just trying to figure out which equation you got to write down and set up so you can solve for x properly, and then you can plug x back in to figure out how many degrees each angle is here. That's what it's asking us to find, the measure of each angle. So as we go ahead and solve for x, we're going to combine the like terms over here on the right side. So we're going to get a 6x here, and then 15 and 57 are going to combine. So it's giving us 90 equals 6x plus 72. And now we just want to subtract 72 from both sides, get the 6x by itself. 90 minus 72, that's going to give us 18 is equal to 6x. And when we divide by 6, we end up with x equaling 3. So at this point, we want to plug 3 back in for x in both of these expressions. On the top one, it's very simple, just 3 plus 15. We can see the answer there would be 18. So for the measure of angle CAD, that's just 18 degrees. But then for the bottom one, we're going to have to plug 3 in here. 5 times 3 first is 15, and then 15 plus 57. And so on that one, we're going to see for measure of angle BAD is 5 times 3 plus 57. I said that was 15 plus 57, which equals 72. So the measure of angle BAD is 72 degrees. And you can just always double check that those two adding together should equal 90, and they do. Now 8 starts off by saying that the ray EG here it's bisecting this angle DEF. So it tells us right away that this is a bisector. You can see it's going to be, these two are going to be the same then. It doesn't show us necessarily congruent marks here. That's not necessarily the congruent marks for each one because there's no distinction between it. It's just all one mark. So really what that's showing us is that this entire angle is 92 degrees. This whole big angle is 92. But we do know that each smaller angle is exactly the same measure. So if we find the one, we can find the other, then the other one's the same thing. And that's what it wants us to find, is the measure of each of these smaller angles in here, which would be the same number. So right off the bat, the whole thing is 92. And this is bisecting this angle. It's bisecting the 92 degree angle. Basically, you just got to cut 92 in half. That's all you got to do. So the measure of the angle of DEG, the top one, is you can just say 92 divided by 2, which is 46 degrees. And so that's the measure of the top one. And I said since they're the same thing, they're congruent. The measure of the bottom one's exactly the same. So the measure of angle GEF, it's also 46 degrees. So there's our answer for number 8. And then for 9, we have QR bisects again. So we have another bisector right here. We want to find the two smaller angles. So same kind of thing, but it's just giving us expressions in this one. So what we do know here, we don't know the angle measure on this bigger one, but we do know that these two are exactly the same. They add up to this, but they're going to be exactly the same. If this is a bisector, then this side is equal to this side, just like this was 46 and that's 46. So this expression is the same thing as that expression. They equal each other. So we can write our equation or set up our equation as these two are going to equal each other. So the 4x minus 10 is going to equal the negative 3x plus 130. So realize that sometimes if things are congruent, you're going to set them equal to each other. Other times, you're going to have to add the expressions together and it's going to equal maybe something larger like 90 for 90 degrees or 180 for like 180 degrees. So as we solve this one, we're going to first add 3x to move the x term over here. So if we add 3x, it's going to give us 7x on this side. So 7x minus 10 equals 130. And then we add the 10 to both sides. Should probably be letting you do this on your own. But that's going to give us 140 degrees, or 140, not just like degrees, but 140 over here. Divide by 7, and so 140 divided by 7, that's going to give us exactly 20. X is equal to 20. So that is the number we need to plug in to the expressions here for x in both of these. So as we start with one of them, it doesn't matter which one you choose. If you plug 20 into this one and figure out the measure of that, it's going to be the same as this one. You don't really need to plug them into both. They're going to be exactly the same result no matter which way you do it. They're both going to have the same measure. So what we can do here is just pick one. I'll pick this one here, 4x minus 10. So that's finding measure of angle PQR, and it's going to be 4 times 20 minus the 10. 4 times 20 is 80, so 80 minus 10 is 70 degrees. So the measure of angle PQR is 70 degrees, which tells us that the measure of this side over here, which would be this side over here, SQR, it says, sorry. It says find the measure of PQR here, and PQS. PQS is the bigger one. So of course this is going to be the same. This is 70 degrees over here on that side. So I'm showing you this here. So SQR here is the same thing, just showing you would get the same thing if we tried this one. If we plugged it in here, negative 3 times 20, which would be negative 60, and then plus 130 gets us back to 70. So we can see whether we did this one or that one, we're going to get 70 no matter what. But now the whole thing, we just know these are both 70, so the whole thing is 140 degrees. So what we can say there is the measure of, right here, we can say that, I'll put up on top here, the measure of angle PQS, and that's our big one along outside here, equals 140 degrees. So if we just found one, we could just times it by 2, or since we found both, we can see we just add those two together to get 140 degrees. Alright, so that concludes our lesson here on 1.5. You want to go on to the assignment, and I'll see you in class. See you on the next lesson.